Shivam Dixit welcoming you all in this beautiful subject thermodynamics, and today we are going to talk about the entropy. Okay, so hello Sujata, Arsh, hello, very good evening. Okay, so let's begin the entropy. So first of all, I would like to share here one very important information for all of you, that this series is basically uh, for GATE students, right? For it is for GATE prospective, GATE point of view. So we all know that uh, GATE in GATE only numerical problems are being asked. So here we are only going to talk about the things, that topics that is basically required uh, required uh, for solving the problem, solving the numericals. Correct. See, as per the topic is concerned, right? Please listen here carefully. As the topic is concerned, this topic is 50% theoretical and 50% numerical kind of. Theoretical things like what is exactly meaning of entropy when macroscopic viewpoint is concerned, what is exactly meaning of physical meaning of entropy, statistical view of entropy, and there is a lot more. So generally when we discuss this topic in classrooms, right, then we used to cover all those things. We used to cover everything, whether it is a theoretical part or numerical part, or the things which is required for numerical as well as theoretical, right? But as in GATE, there are rarely chance that theoretical questions are being asked, right? So mostly numerical questions are only going to ask. So basically in this lecture of entropy, we will learn only those things which are actually required for solving the numerical problems. We are not going to discuss about what is the physical meaning of entropy, what is the physical meaning of entropy of universe, what is the what is the statistical meaning, what is Boltzmann law, what is the Boltzmann equation, how to find out the absolute entropy and all. This we are not going to discuss, right? Because these things are not related to finding out the entropy change for any system numerical problem is concerned, right? So I hope that you all are aware of this particular thing. Let me talk about this, that in case of entropy, second law for a process, I told you yesterday also that there are two parts of the second law of thermodynamics. One is related to the cycle, and for cycles, if you see, like heat engine is working on a cycle, refrigerator, heat pump. So we have already discussed what are the parameters and what are the second law of thermodynamics for cycle, especially Clausius inequality, right? Then here we are going to talk about second law of thermodynamics for process, entropy principle, entropy of a system, how to find out the entropy, and question and analysis, right? So basically this is very much important, right? As far as numerical problem is concerned, this entropy of a system, entropy change of a system, how to find out entropy change of a particular system, that is very much important. Numericals are going to be based on this only. There is importance of this entropy principle also. Entropy principle also have very great significances, but unfortunately most of the significances are either theoretical based, which are not required for GATE exam, or which are basically based on the how to find out the entropy changes, right, for a particular system, surrounding, and universe. Okay, so we'll discuss all those things in detail. So I hope you all are ready. Sir, I am ready to crack another exam, that is what is that, 𝐂𝐨𝐮𝐬𝐞. Okay, you are, I think, Sai Kumar, you are from Telangana or Andhra Pradesh. That's why you are talking about that GENCO and DISCOM, right? Okay, because of going to country takes time, so I am ready for it. Very good sign, very good decision. I appreciate that. Okay, let me talk about the second law of thermodynamics for a process. So in yesterday class, we have already discussed about the second law of thermodynamics for a cycle. That is nothing but a Clausius inequality, means cyclic summation of dq by t, cyclic integral of dq by t is less than or equal to 0, less than or equal to 0. Now if we find out the same thing, right, if I use, if I try to find out the same thing for a process, then one property will introduce, and that property is called as entropy, right? And that is represented as ds dq by t reversible. So basically, from here I can say, for any process, please listen here, right? For process, if I tell you that ds is exactly equals to dq by t irreversible, so please try to understand dq by t reversible, correct? ds is always equals to dq by t reversible. I would like to share here one very important information, that entropy is a property, right? Suppose if we have 2 points, 1 and 2, right? 1 and 2, so between these 2 points there is, this is S2, for example, this is S1. So initial entropy, let's say S1, and final entropy is S2. Then ds is basically S2 minus S1, and that value is basically fixed. Please try to understand, entropy is a property. It does not depend upon the path followed by the system. Whether it is a reversible process or irreversible process, entropy value is going to be same. So what I'm trying to say, that between two states, right, between two states, if number of reversible processes are there, between two states, if number of reversible processes are there, then for each reversible process, the quantity dq by t reversible is same. The quantity dq by t reversible is same, and this quantity dq by t reversible is called as what? Entropy. So if you really want to learn the entropy, then one thing you have to throw from your mind, that ds is equal to dq by t. ds is not equals to dq by t. ds is not equals to dq by t. ds is equal to dq by t reversible, reversible, reversible. So what I'm trying to say, between these 2 points there are infinite number of processes are possible, right? Infinite number of processes are possible, correct? Out of this infinite number of process, every process have different value of dq by t. Every process have different value of dq by t, and out of this infinite number of processes, there is one reversible process. There is one reversible process, and for this reversible process, the quantity dq by t reversible is maximum. The quantity dq by t reversible is maximum. This maximum value of dq by t between two states is known as entropy. Even if you find out, let's say here this is process A, B, C, D and E, right? So C is basically, you can see it is a reversible. So whenever we calculate the entropy, then we'll take the dq by t of a reversible process, okay? But it does not mean that for irreversible process entropy is different. No, entropy is going to be same. Means entropy is a property, does not depends upon the path followed by system. It is only depend upon the end state. So if you look at these five processes, if you look at these 5 processes, then end points of these 5 processes are always same. So the entropy change is going to be same for all these 5 processes, right? And that is exactly given as ds is equal to dq by t reversible. For all other irreversible processes, the dq by t irreversible is always less than dq by t reversible, means less than entropy. So, and that is not entropy at all, right? So if I talk about dq by t irreversible, then this value is always less than ds. This value is always less than ds, and this is not entropy at all. So if you want to make it entropy, if you want to make here equal sign, so you can see that right hand side value is less. Right hand value is less. If right hand side value is less, right hand value is less, it means that right, you have to add something here, right? You have to add some quantity. Let's say I'm writing here delta s generation, so now it will going to be equal. Now it is going to be equal, okay? So these two equations are there, right? And entropy is a property, so there is no any problem, correct? Sir, I am doing BTD lectures from Parakram batch. Thank you for your best guidance. Thank you very much. And I hope you are going through the topics. So here, right? So okay, fine, no problem, right? So I just want to ask, what are you doing here, right? When you have already taken paid batch, right? when you have already taken the paid batch, you are already enrolled in the Parakram batch, you are already covering basic thermodynamics there, then what are you doing here, Mr. User? What are you doing? Sir, like dq by t equals to 0, reversible in cyclic. There is nothing like cyclic process, never ever called is like this. There are some books which are writing like cyclic process. What do you mean by cyclic process? Whether it will be a cycle or a process, that's why you people are always confused. You people are thinking that there is one process, there is one cyclic process. No, it is nothing like that. Always say either process or cycle. Cycle is different, process is different. Cycle means there could be number of processes in such a way that the initial and final state is same. So never ever used to use this word cyclic process, because cyclic process will always confuse you. Even though I agree that there are some books which are writing this word cyclic process, but I don't find any significance of this, right? So either you say cycle or you say process, otherwise you will always be confused, correct? And please try to understand both are exactly different, because that's why you are here, you are confused, because you are thinking that dq by t reversible. So for cyclic process it is going to be 0, so ds value is 0, right? For cycle you say, right? And for cycle entropy change is 0, that is true, because for cycle not only entropy change, any property change is 0, because initial and final point is same, and properties are depend upon the end states. End states are same means entropy change, entropy is same, entropy change means same, means the change is different, change is also 0, correct? Sigma, why do youth nowadays like this and waste their life creating sadness? Oh, I want, right? I just come to say thank you. Okay, user, thank you, welcome, thank you, bye bye. So thank you for coming here. I think this user person is attending the recorded classes. Recorded class, that's why he is, I think you are studying from Khazana, that's why you are not able to express your gratitude during the class, and you need to come to the YouTube and sharing your gratitude. But thank you very much for coming here, and thank you very much for sharing your views on basic thermodynamics. As far as subject is concerned, I will try to improve every single time, and hope you are going to get a very good thing, right? Okay, so he failed with the partner, his age 23. Who failed? Why? Okay, 21. My friend brother died. Yeah, I understand. I thought of this. Okay. Okay, thank you. Bye bye. Okay, let's talk about the another point, right? So here few more point I would like to share here, that between two states, if number of reversible processes are there, then for each reversible process the quantity dq by t reversible is same, and this quantity dq by t reversible is called as entropy. Now please try to understand, dq by t irreversible is not a property. Dq by t irreversible is not a property, it is just a quantity which is always less than entropy. Entropy is a property, so it does not depends upon the path followed by the system. So whether it is a reversible process or irreversible process, the entropy change is going to be same, right? So in order to find out the entropy change of irreversible process, we need to replace the irreversible process with a imaginary reversible process, and then we'll take the dq by t of that reversible process, right? Okay, fine, perfect. One more point I would like to share here, that between two states infinite number of processes are possible, and for every process the dq by t is different. Basically the dq by t is different, and and out of these infinite number of process there is one reversible process, and for that reversible process the dq by t value is going to be maximum, and this maximum value of dq by t is called as entropy. Okay, so I hope you people are able to understand I hope you people are able to understand that what is the meaning of macroscopic meaning of entropy. Okay, there is one question from Hemu, right? Hemu. Okay, Hemu, tell me, sir, why second law of thermodynamics gives 100% efficiency, possible or not? Why? Okay, very good. Hemu, I think you are not aware of the meaning of law, right? I think you are not aware of meaning of law. What is law? So laws are the statement which are universally truth. Laws are the statement which are universally truth but can't be proved mathematically. But can't be proved. No one can prove. No one can prove that why complete conversion of heat into work is not possible for a cycle, right? No one can prove this, right? I'm telling you, no one can prove this. Clear? It is not possible at all, because laws are the state. That's why it is needed to make a law, right? So laws are the statement which right which is actually comes from the experiments, which are always truth and comes from experiments. Okay, so it is comes from experiment, Hemo, right? So never ever ask this question to anyone, because otherwise he will, like suppose you are asking this question to someone, then he will think that you are not aware of what is basically meaning of law. For example, Newton's law is there. Newton's law is saying that if a body is at rest, then he wants to remain at rest. He wants to remain at rest. And the property which property of, like this property of the say any system is called as inertia, right? So now basically this is a law, right? He have done lot of experiment, right? He have done lot of experiment, and on the basis of you cannot say that prove the first law of thermodynamics, or you cannot say that prove the law of conservation of energy. No one can prove, right? Only experimentally it can be proved, right? You just take experiment and you just perform that experiment, you will find that this statement is correct. You will find that this statement is correct. Okay. Okay, let's talk about another very important point, that is entropy principle, right? Or entropy of isolated system. So entropy principle is saying that the entropy of a system, please listen here carefully, entropy of a system may increase or decrease or become constant. It is depending upon the how the process is going to be take place, or I can say that what kind of heat transfer, heat interaction may take place, correct? So entropy of system may increase or decrease or become constant. Entropy of surrounding also may increase or decrease or become constant, but entropy of universe never decreases, right? Entropy of universe never decreases means, as per the entropy principle, ds of universe is always greater than or equal to 0, or I can say ds of system plus ds of surrounding is greater than or equals to 0. So this is basically our entropy principle, or also called as principle of increase of entropy, right? Clear? Okay, so how to identify reversible process, not cycle? Okay, in cycle we have dq by t equal to 0 for reversible, okay, and less than 0 for irreversible. How identify in the process? That's what I'm telling you. That's what, see, yesterday whatever I told you, lifelong, right? Life love, whatever I told you yesterday, that was basically related to the cycle. That's why I use here term cyclic summation of, right? So as like for cycle, if you look at, for cycle number of processes will be there, correct? Number of processes will be there. So for each process, if you calculate dq by t, right? For each process, if you calculate dq by t and sum it, right? If you sum it, then if all the processes are reversible, right, then the summation of all the processes, summation of dq by t, all the process will come 0, right? If any one process is, even any one process is irreversible, or all processes are irreversible, then cyclic summation of dq by t value will come less than 0. And this is a law. This comes from a law. Please try to understand. This comes from law. You cannot say that, sir, why, how, prove it. No, no one can prove this. No one can prove this, right? No one can prove this because it comes from the law, right? It's come from the law. If you want to check, you can take any cyclic device. You can take any cyclic device. You take heat engine, refrigerator, or any heat pump or something. You just perform this. You just find out how many processes are there. Just calculate dq by t for all the processes. Sum it. If it is a reversible engine, then it will come 0. But actually, reversible engine is not exist in this world, right? So obviously, the value is always come negative. There is no any single chance. There is no any single chance that value will come positive. If you want, you can go in your lab, take any engine, identify the processes, just calculate the dq by t for various processes, sum it, it will always come negative. It will always come negative. Okay, so that is basically the thing, right? Okay, now when I'm talking about process, right? So one more thing I would like to tell you. There are two things are there, how to identify whether it is a cycle or a cyclic question, or cycle question or process question. So in our course, right, lifelong, in our course, only 3 cyclic devices will be there. Either it will be heat engine or refrigerator or heat pump. So in any question, if it is heat engine word is there, refrigerator word is there, right, heat pump word is there, then it will be a cyclic device. Then it will be a cyclic device, and all those things are going to be used which I discussed yesterday class. Correct? Okay. And one more thing, cycles are performed like continuously. Cycle, our engines are performing continuously, right? Refrigerator is performing continuously. So there is a cycle, right? So you can see that, so let's say IC engine is there, right? So suction will be there, compression will be there, expansion will be there, combustion will be there, then exhaust will be there, expansion will be there, right? So all these processes will be there. Then once exhaust will done, then again suction will be there. Again the cycle will repeat. So cycle is basically for if you want to make a device which work continuously, then it must operate on a cycle. It must operate on a cycle. Whereas process will start at a point and it will end at a point, right? So for example, I went to let's say Bangalore. I went to Bangalore. It is a process, because I'm not going every day to the Bangalore, but going to office, come back to, and coming to home and again going to the office, this is basically what a cycle. Every day you are performing this. You are going to the office, you are come back to the home, you are going to the office, you are come back to the home, right? So this is basically what a cycle. So cycle is continuous, where process is always for finite time. So once you will read the question, then you will get to know whether the things are for for a period of time, whatever it may be. It may be 1 hour, it may be 2 hours, it may be 100 hours, it may be 2 days, 3 days, 5 days, 1 year, right? So if it is for certain period of time, then it is a process. If it is a continuous device, if it is working continuously and repeating their processes, then we'll call it as a cycle, right? I hope you are able to understand, right? So why does entropy always tend to it? Again, Himu, you are asking the wrong question, right? Again, you are asking the wrong question, right? This is basically called as my shortest answer for your second law of thermodynamics. Second law of thermodynamics for a process. Please try to understand. Okay, I can tell you, actually I can give you the exact answer physically, right? Physically I can tell you the answer, right? Don't worry about it. But for you, I'm telling you the most shortest answer, that it is a second law of thermodynamics for process. It is a second law of thermodynamics for process. Physically, statistically, see, macroscopically or classical thermodynamics, you cannot prove it. You cannot even prove any way. You cannot prove it, but you can at least understand. You can at least understand why entropy of universe is always increasing. Why entropy of universe is always increasing when it comes to the statistical meaning, physical meaning, right? When it's come to the physical meaning. So I don't want to go into it, but little bit I can tell you that entropy is basically measurement of, it is a measure of molecular randomness, molecular disorderness. And disorderness is nothing but you people are asking, that's why I'm telling you. You people are asking, that's why I'm telling you, right? Very good, lifelong, right? So you people are asking, that's why I'm telling you, but it is not relevant for the solving the numerical problem, but I'm telling you for your information that what is physical meaning of entropy. So entropy is a measure of molecular disorderness. What is this disorderness? Disorderness means uncertainty about the position of molecule at any instant of time. What is the uncertainty, right? Means where could be the where what are the possible number of positions where that molecule can exist. If I more emphasize, then the in 1877 Boltzmann given the entropy as a Boltzmann defined the entropy as a thermodynamic probability. Thermodynamic probability. What is thermodynamic probability? I'll tell you. And thermodynamic probability W. And he have given one equation, that is S is equal to K ln W, where K is a Boltzmann constant. The value of K is 1.32 × 10⁻⁻23. Right, that is the value of K, right? So now if you understand what is this W, then you can understand. W means thermodynamic probability. Thermodynamic probability is the possible microscopic states available to identify the position of a molecule. Mean how many ways you can identify a position of molecule. Correct na, right? So that is basically going to represent the represent the entropy. Now if you talk about any system, let's say I'm talking about this mouse. So entropy of this mouse may increase or decrease or become constant. Entropy of surrounding may increase or decrease or become constant, but entropy of universe will never decrease. Means disorderness of universe is continuously increasing. Why? Because our universe is trying to come into the equilibrium position, right? I think you may have heard about our sun, right? Our sun also have some life, 10 to the power some 12 years. What will happen after 10 to the power 12 years, right? Whatever things are going on inside the earth, inside the sun, that will going to be finished, because that will come equilibrium with the surrounding. That sun itself will come equilibrium with the surrounding. Once it will come equilibrium with the surrounding, then it will be treated like a black hole, right? And there will be no any significance of any planet when earth itself when sun itself does not have any energy. So this is for one particular solar system. Similarly for other solar systems also. So everything is trying to come into the equilibrium. That is a nature. What is exactly the nature? Right, right. What is exactly this, sir? Did you see the CJP protest? I seen that. I must say it is a brutal, right? It should not be there. It should not be there. And like we must have to support our students, right? We must have to support any, not the wrong way, definitely, right? Not the wrong way, but at least we need to support them in a correct manner, like whatever way you can find, right? I will not suggest you anything because it's your wisdom, right? But okay, please try to understand one thing. So okay, so I have told all these things, right? So this is basically the meaning. So in this universe, I was saying one particular point that that there is a law in the nature. There is one law in the nature that everything wants to be in equilibrium. Everything wants to be within equilibrium. Everything wants to be in equilibrium, right? Means suppose if I have more temperature, let's say my temperature is more, right? If my temperature is more, right, my temperature is more, and your surrounding temperature is less, automatically we need not to do anything. We need not do anything. Automatically heat will transfer to equate the temperature. Please try to understand what I'm trying to say. What I'm trying to say, every single phenomena in this whole universe is basically working on this particular principle. You will not believe, but if you will not believe in this whole universe, in this whole world. Okay, talk about science, right? In this whole science, if I write 10 most important equations, 10 most important equations, including electronics, electrical, mechanical, civil, this blah 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 blah, robotics and all, right, everything, then in that, out of those 10 equations, there would be one equation that is related to the entropy. Entropy is so much relevant because it is everywhere. The law is everywhere, and this is based on the very simple things, right? It's not easy to digest sometime, but it is actually at very simple things. The thing is very simple, that everything wants to come into the equilibrium. We all want to come into the equilibrium, everything, right? And nature is defined like that. For example, I have told you that, let's say my temperature is more, surrounding temperature, automatically I will reject heat. There is nothing else is possible. Automatically, somewhere pressure is more, somewhere pressure will less, automatically flow will take place, the things will take place, so that it will come into the equilibrium. Something have more energy, it will automatically come to the lower energy level, right? And coming, see, my dear student friends, if you look at any phenomena, Hemu bhai, right, Hemu bhai, if you look at any phenomena in this whole universe, what is that phenomena? That phenomena is basically conversion of one form of energy into another form of energy. That's it. I'm talking, that is also conversion of one form of energy into another form of energy. I'm dancing, this is also one form of energy into another form of energy. We are walking, that is also like vehicle, fan, light, board, computer, every single thing is converting one form of energy into another form of energy, nothing else. And the very important point, if you look at the broader perspective, then actually high grade energy is converting into low grade energy. So basically, Hemu bhai, if you understand this point, then in this universe, what is happening? High grade energy, low grade energy, high grade energy, low grade energy, high grade energy, low grade energy, high grade energy, means high grade energies are converting into low grade energy, right? So in this universe, low grade energy is increasing. Low grade energy means heat. Let's say you have fuel, you will have chemical energy, high grade energy, converting into low grade energy, right? You have light, electricity, high grade energy, converting into low grade energy. Engine, it is producing work, and work is going to the surrounding, it is going as a heat only, low grade energy. So every single, even I am moving, right? I have internal energy, I have energy, that energy is going in form of heat. So everything is basically, the final form of energy is always heat. The final form of energy is always heat. You are getting my point, right? So basically, if you see in this universe, low grade energy is increasing, low grade heat is increasing, heat is increasing basically. And whenever heat is increasing, heat, right, thermal energy, you can say, heat is not the correct word here, thermal energy is increasing. If thermal energy will increase, entropy will also increase. You can see that ds is equal to dq by t reversible. Whenever, if you add heat, in any system, entropy will definitely increase. So what we are doing in this universe, bhai, what we are doing, we are simply supplying the heat, different manner. So entropy of the universe decrease. Entropy of universe can only decrease if it reject the heat to the out. It will reject the heat. Then that is the only way. The only way to decrease the entropy of universe to reject the heat somewhere. But universe means what? Everything. Universe means everything is universe. Out of universe, what is there? Nothing is there. If nothing is there, then how can it reject the heat to the nothing? No, because for rejecting heat, if something is rejecting heat, then it must go somewhere. So something should be there to receive that energy, but nothing is there outside the universe. In our imagination, in our hypothesis, universe is everything, my dear student friends, right? So I hope you all are able to understand. Generally, I used to take approximately 2 to 3 hours. Generally, I used to take 2 to 3 hours to only explain the entropy, physical meaning of entropy. I'm very good in that. I'm telling you, I'm very, very good in that. But unfortunately, that part is not, relevant for the numerical problem. Actually, I'm very much good in that, right? You will sometime when I, because it's my favorite topic, right? Physical meaning of entropy is my favorite topic. When I used to teach this, sometimes students are, darne lagte student, right? Sometimes they are happy, sometimes they are sad, right? So it's a very interesting topic, but unfortunately we are here only for gate perspective. So sometime it will be needed, like sometime I will tell you, because it is very much important for interview perspective and for knowledge perspective. So someday I will try to explain you in a better way, but today we are moving ahead, right? Okay, please excuse me. Okay, let's talk about the TS diagram, right? One another very, very important point, that is TS diagram, right? Let's talk about the TS diagram. So if I talk about the TS diagram, let's say we have a TS diagram here, right? TS diagram, my dear student friends. So let's say I'm drawing any process, right? Let's say I'm drawing any process, right? And this is any process, that is, right? Okay, now we already know that ds is equal to what? Ds is equal to dq by t reversible, right? Dq by t reversible. So what is value of dq, right? The dq value is tds, right? Dq reversible basically. If you want to find out q reversible, then you have to integrate both the sides. So you will get an integration 1 to 2 tds. So basically this will give you the heat transfer in a particular process. You can calculate the heat transfer for a particular process with the help of this particular equation. And even there is one another way, right? If I want to represent here, then at given t, right, please try to understand, at given t, if I supply in very small amount of dq, very small amount of dq, then there will be little bit change in the entropy, that is called as ds. So if I calculate the area of this particular strip, area of strip value will come t into ds. Now if I project it from 1 to 2, if I calculate this complete area, if I try to find out complete area, then total area when projected on entropy axis in TS diagram is integration 1 to 2 TdS, right? And that is nothing but a reversible heat transfer. That is nothing but a reversible heat. So here one more significance you get, right? There is one very important significance of TS diagram, that the area under the curve, when projected on entropy axis, in TS diagram gives, right, area under the curve when projected on entropy axis in TS diagram gives reversible heat transfer, So I hope it is very much clear to you. Is it clear to you, everyone? Shall I move ahead? Now I'm going to talk about the entropy, how to calculate the change of entropy of any system. Right? So first you need to check what is your system, right? The system can be finite temperature body, or I can say another one is reservoir. So only two things are there in this classification, in this whole universe. Two things are there only. The first thing is finite temperature body. So a body where if we transfer the heat, to any body and its temperature is changes, then it is a finite temperature body. If its temperature is not changes, then it is a reservoir. Very simple logic. Correct. Generally, reservoirs are infinite mass bodies, and finite temperature bodies are finite mass bodies generally. Now, this finite temperature body could be like gas, which I am in our course it is only ideal gas discussion, and then or solid liquid. Only three things are there: solid, liquid, and gas. Right? Don't talk about plasma state, okay? Because that is a molecular thing again, and we are talking about classical thermodynamics in macroscopic viewpoint. That is a microscopic phenomena. Then another one is reservoir. Now, what is this reservoir? Is either source or sink. Either source or sink. Clear? Okay. Now, if you want to find out the entropy change of ideal gases, this chart is very much important. If you know about this chart, you can solve any problem. So, if you want to find out the entropy change of any ideal gas, then ds is equal to or I can let S2 minus S1. So S2 minus S1 is equal to, there are three formulas: CV ln T2 by T1 plus R ln V2 by V1. That is first formula. Same formula can be written as S2 minus S1 is equal to Cp ln T2 by T1 minus R ln P2 by P1. Same I can write here, S2 minus S1 is equal to Cp ln V2 by V1 plus Cv ln P2 by P1. You can use any one formula, right? You can use any one formula as per your convenience. So as per your convenience, you can use either this formula or this one, right? There is no problem at all. Let's talk about solid liquid. In case of solid liquid, final entropy minus initial entropy is equal to mc ln T final by T initial. Source. What is source basically? Source is basically a body, right, which can supply, let's say it is maintenance, which can supply any amount of heat, but temperature will not change. So as the temperature will not change, this is our system. So ds value will come minus Q1 by T1, because the heat is coming out from the reservoir. So entropy is like sun entropy is continuously decreasing, right? Whereas other planet, other thing which is getting that heat, that entropies are actually increasing, right? Okay, but overall entropy will increase only, right? Now sink is basically something that where we can supply any amount of heat without any temperature change. So if this is system, basically in sink we are heat supplying, so it will come positive, so Q2 by T2. Right, and one more thing, that phase change, right? ds due to phase change, that is equals to latent heat by T saturation. So this is the chart. With the help of this chart, you can solve R means universal gas constant. Characteristic gas constant. R is the characteristic gas constant. Kilojoule per kg Kelvin. Okay. So this is basically, if you know about this particular chart, you can solve any question. If you know aware of this particular chart, you can solve any of the problem. There is no any issue. There will be no any issue, right? So let's solve this particular problem. So I'll request you everyone that please try to solve this. Please everyone try to solve this. Everyone please try to solve this. Please solve this. Yes, very good. So they are asking that air at a pressure of 86 kilopascal. So initial pressure, I can say it is a P1, right? And a specific volume that is given as a V1 is heated at constant pressure. Now pressure is constant, please try to understand, and reaches to the till this temperature T2 value. Initial temperature is not given, right? Okay. Air is assumed to be ideal gas with the constant specific heat. Its gas constant is given, ratio specific heat given. The change in the specific entropy of the air, right? Specific entropy you need to see. It is very easy, right? What we can do that, which formula will be best suited for it? Pressure is constant, so we'll obviously use pressure one, and air pressure is this one, and specific volume is given, the heated at constant pressure till reaches to the 6. Okay. Okay, the first we'll calculate initial temperature. So I'll write here P1 V1 is equal to R T1. So what is value of T1? T1 value will come, P1 is 86 into volume is 1 divided by R value is 2.287, right? 0.287. So this value will come 0.287. So this value will come 86 divided by 0.287, right? So this value will come approximately 299.65 Kelvin, right? Now T2 value will be how much? That is 273 plus 627. So this value will come 900 Kelvin, right? Okay. Now ds is equal to what? ds is equal to Cp ln T2 by T1 minus R ln P2 by P1. But P2 and P1 is same, so this term will be 0 because P2 is equal to P1. So here remaining is Cp. Cp value I can write here. Cp value for 0.287 means it is a air property. So this value will come 1.005 ln. T2 value is 900 by T1 value is approximately 300 or 299.6. 900 by 299.65 ln of this value into 1.005, right? So this value will come 1.104. 1.104 kilojoule per kg Kelvin. So A is going to be your correct answer. A is going to be your correct answer. Yeah, okay, you can write, no problem. Yes, very good. Okay, solve this problem. Any other problem is there? Okay, these two. LM3, yes. Okay, you can approximate. Solve this particular problem. Okay, I'm giving you this problem as a homework, right? So this is basically homework for you. So I'll suggest you to solve this problem, even you will able to solve. If anyone is not able to solve this problem, right? If anyone is not able to solve this problem, then what they need to do? They have to join this particular channel, right? This is my Telegram channel, Shivam Sir Physics Wallah. So join this particular channel, and if you have any problem in thermodynamics or fluid mechanics or any career related doubt, anything, any guidance if you require, then I will definitely help you. So you can search in Telegram Shivam Sir Physics Wallah, I'll get here. Okay, so this is all about today's class. So I hope you all are able to understand. Let's meet tomorrow, and tomorrow we'll discuss a very interesting topic, that is exergy. Thank you, bye bye.